On the nature of the universe. To view the universe in the form of alternating currents, as an alternator, all properties can be considered conserved in expression. For an object-oriented paradigm to suit polymorphism, conservation of properties is required to be inherent. Using this approach, the mechanics of relative gravity address the dynamics of what is referred to as a relative force for the universe. Considered common between the four known forces, the mechanics describe relative force as the common property or combination of shared properties which are observed in conservation. At the most fundamental or basic level of measure, these properties consist of energy that exists in some realm of context of time and dimension. Things are considered related by the sharing of properties that are seen as fundamental between them. As a basis for symmetry, a relationship can be seen established with respect to disposition. Newton and Kepler are understood to view a solid object's disposition, like matter, to express force as a fundamental in a relationship between entities when one is acted upon by another. But like solid objects or even for light, the exchange of dispositions between even an anode and cathode are considered to share similar fundamental properties. Solid objects like matter are further affected by or effect a discharge of electrical energy. Here, they are considered to share the same fundamental properties consisting basically of some measure of energy, the speed of light and an aspect of dimension. Addressing this, relative gravity's abstract definition is, A. The potential energy of bodies purported as amplitude in kinetic energy, and expressed as some spatial time in the form of a resonant frequency potential that is shared between them. B. The resonant frequency is considered a shared fundamental that is measured through their body's level of superposition. C. The kinetic expression is subject to the disposition of the body's potential uniquely. Modeled as an object-oriented paradigm, relative gravity is to demonstrate properties of symmetry for the four known forces. It is intended to be analogous to an Occam razor. This is where, although separate and distinguishable, contrary to popular thinking, here all forces are seen as part of the same thing. Like in the case of light, properties are considered polymorphic in an object-oriented hierarchical way. As theory, this is specifically in the nature of how, like a water droplet demonstrates its body in the vacuum of space, black holes, galaxies, matter and particles are held together in a manifold of what is referred to as a uniform relative force, or earth. Earth model is considered a basis for unification theory for the four forces in relative gravity. Relative force is seen as what is common between them when given their context in space and time. As a paradigm, relative gravity, RG, includes the proposal of four laws. They are detailed later. Each consists of a number of related observations. Combined, they are for describing in an object-oriented manner, a relative force considered common to all the four known forces. That is, what is called the strong, weak, electromagnetic and gravity. As an abstract property, relative force is considered exhibited in practical or concrete applications uniquely for the four known forces. Relative gravity's four laws are meant to be based on observations of truth. They are not considered absolute truths themselves, as observations are considered here strictly a subjective phenomenon. For that matter, all scientific law referenced in this essay is regarded this way. In other words, humans are not all-seeing, which means nothing can be absolute. The theory is intended to remain aligned with the views of Kepler, Newton, Einstein, Faraday, Tesla, and Hawking. The theory interprets, or in fact interpolates some of their work. For the paradigm they are related in the abstract for shared properties. Case in point, you must have a circle before a wheel can exist. That is, although the need of the wheel might help you discover the circle as a basic property that is shared with other things, for example the sun and moon. In each case, it could be considered a polymorphism of a property's inheritance expressed in a practical application. The views of Kepler, Newton, Einstein and Faraday normally apply to the physical context where intended. In other words, in how they see their particular wheel. In each case though, their properties, in an object-oriented way, are seen as part of their collective circle. In the theory, it is to demonstrate symmetry in the physical laws. As a simple example, one would think in terms of Faraday for explaining the principles demonstrated in the diagram below with respect to induction as a force. But if viewed as abstract properties for applying to black holes or bodies in space, like a magnetized wave that transverses the universe as a pulsar or quasar, while perhaps electrifying dark into light matter in its wake, then Newton's laws also perhaps can show symmetry in derived bodies.
Relative gravity proposes a new perspective on the disposition of objects and the fundamental forces of the universe. It suggests that even seemingly disparate entities, such as solid objects and light, share fundamental properties when it comes to their disposition and interaction with one another. This includes the exchange of dispositions between objects like anode and cathode, which are considered to share similar fundamental properties related to energy, the speed of light, and dimension. In the context of relative gravity, the abstract definition includes potential energy of bodies expressed as amplitude and kinetic energy, and resonant frequency potential shared between them. This resonant frequency is measured through their level of superposition, with kinetic expression subject to the body's unique potential. Relative gravity operates as an object-oriented paradigm, aiming to demonstrate symmetry among the four known forces, similar to Occam's razor principle. The theory posits that all forces, despite being separate and distinguishable, are part of the same underlying concept. Like water droplets in space, black holes, galaxies, matter, and particles are held together by a uniform relative force, termed as THF model, which serves as a basis for unification theory. Relative force, common to all four forces, is observed within the context of space and time. Relative gravity introduces four laws, each based on observations of truth, although not considered absolute truths themselves. These laws describe the relative force exhibited uniquely by the four known forces: strong, weak, electromagnetic, and gravity. The observations are considered subjective phenomena, contributing to the understanding of the universe's dynamics within the framework of relative gravity. Suggests viewing the universe as a dynamic system of alternating currents, akin to an alternator. In this framework, all properties are considered conserved in expression, which aligns with the principles of object-oriented design. Relative gravity addresses the dynamics of the universe by describing a common force shared among the four fundamental forces. This force is characterized by the conservation of shared properties, such as energy, across different contexts of time and dimension. Overall, the lecture highlights the interconnectedness of properties in the universe and the importance of conservation in understanding its dynamics. Contributions of Kepler, Newton, Einstein, and Faraday are typically understood within their intended physical contexts, akin to how each scientist perceives their particular wheel or area of study. However, in an object-oriented framework, their properties are seen as part of a collective circle, demonstrating symmetry in the physical laws. For example, one might typically associate Faraday's principles with explaining electromagnetic induction in a specific context. However, in the abstract realm of relative gravity, these principles can be applied to phenomena such as black holes or celestial bodies, where electromagnetic waves traverse the universe, potentially influencing the transformation of dark matter into light matter. In this way, Newton's laws, which traditionally apply to classical mechanics, may also exhibit symmetry when applied to derived bodies or cosmic phenomena influenced by electromagnetic forces. Relative gravity acknowledges the subjective nature of scientific observation and interpretation. All scientific laws referenced in the theory are regarded as objective phenomena, understood within the limitations of human perception and understanding. This perspective aligns with the views of prominent scientists such as Kepler, Newton, Einstein, Faraday, Tesla, and Hawking, whose work is interpreted and interpolated within the relative gravity framework. For example, the theory highlights the fundamental property of a circle, which must exist before the invention of a wheel. This illustrates how basic properties are shared among different entities, such as celestial bodies like the sun and moon, and are fundamental to understanding the universe's dynamics.